So this week, we'll be going methods and numeric types. That's a big thing. So first off, methods we covered last time. Let me open up IntelliJ. But so yeah, just like a quick review, it has the 3 required parts: the return type, the name, and the parameters. And then just talking about how to invoke method, one thing we're going to add is the concept of scope that's not unique to methods, but we're going to go over it just a little bit. So this was project 1 stuff. That's fine. This is fine. Actually, I think that stands for program 1. Okay, so getting rid of all that. So like I said last time, you've seen a method before. Let me zoom in on this. You've seen a method before. Main in itself is a method. The 2 things we're not going to cover just yet are public and static, because that gets into, again, the classes. But we still will be using the static keyword. Static just means that if we didn't have static, here, I'll show you what it means when we don't have static when we get there. But the 3 key components are the return type, in this case, a lack of one, the name of the function, and then the arguments. In this case, it is a single array of strings with the variable name args. Theoretically, in your readings this week, you'll be covering arrays, so hopefully that'll make a little more sense to you. We'll talk about that next week. But just you could think about this as this is just like int args. Same concept, though for main, it is specifically string brackets, because we'll get into that later. So last time I think I used the add function, so static int for my return type, add int A, int B, int C. And so this is a pretty straightforward function, a method. And you'll see that it's mad at me because I didn't return anything. So maybe at the beginning when you're writing a function, just return something. And in this case, I returned 1 because the return type has to be an int. So 1 is an integer. That means I could do like int x equals 1. And x is an integer, so I can return x. So you can return anything that can be stored in that value. And see right here, it's highlighting x in yellow. Oh God, what? There it goes. It's highlighting x in yellow here because it's redundant. You can inline the variable, and so it's just return 1. So yeah, this is the return type right here. That dictates the type of information you can return here. And that's super important because up here, if we wanted to declare an int, let's say int var1, and we said var1 equals add, and then passed in whatever values, we're not using them yet, so these aren't important, but 1, 2, 3. This dictates saying, hey, this variable is an int and this return type is an int, so this makes it a lot easier for the compiler to just skim it and read like, hey, yes, we can assign var1 to the add function because it returns an int. If it was void, meaning add didn't return anything, we couldn't do this because the required type is int, but the provided type is void, which is a lack of anything. Maybe on another scale, we could do like return string. So it's supposed to return a string object. So getting the method to work, we would make this like a string, hello. And then right here, this is bad because it needed a string. So this right here dictates, even if the function doesn't work just yet, like if you're still messing with it, the return type is what tells the compiler that this is valid, like if you're using it on some other line. So yeah, let's fix this to 1. And here, let's actually implement it now. So we'll do int to return. I can spell. So with this, we're going to return this. And again, to return is a variable, so it could be called anything you want. And actually, with this just a single line concept, you really can just inline it, is what that's called. So it just returns A, B, C. Don't have to have a variable for that, but you can if you want to. You can do that. Okay, so return type, method name. So that's the method name is how like you actually call it. You say like this method specifically. And then parameters are what you pass in, and see we're using these parameters down here. And IntelliJ, the IDE, gives you a helpful little tip. I know some people had questions about it when we were doing like P1 random with that limit, because if you did here, if we did P1 random RNG rng.nextInt, and then they did like 13. Why is this mad? Oh, equals new p1 random. There we go. So like right here, if we got p1 random nextInt 13, it should be yelling at, not yelling at me, but int var2 equals rng.next int 13 plus 1. Okay. I usually did. Whatever. And the project, some people were getting confused because it put like the word limit here. Oh, it put the word limit and a colon, and you can see that up there. Maybe we need to compile it once. No, still no, whatever. But it shows right here, like this little ABC. So sometimes that shows up, and it tells you what the parameter variable is. So if you actually make these, you call it like first operad, second operand. So these are very long variable names. Did I misspell that? Oh, that's fine. So first operad. So like if you actually call these something up here, you can say like, oh, fire operad first. So right here, it like tells you what those variables are, and so that can be useful for some people as you're implementing the code. Okay, so yeah, return type name parameters. You can, so all those are the required parts of a function. And if any of those are different, it can make the function different. So if we did, so we have this right here. I'm going to turn this back to A, B, C, just because that makes it easier for me to talk about it. Not taking a line. If we did static int add and then nothing, or maybe static void add day int b int c. This actually might still be mad. Oh no, that's fine. Okay, cool. System.out.println void return type. Okay, it's mad because I'm not using that. A plus B plus C. Okay, no, lied about that one. That might just be a programming 2 thing. Doop. Might be a C++ thing. Anyways, so the parameters, okay, well, still this is valuable information to show. Because if we give them to you on a test or something, woo. But see, right here, if you've got a different parameter, it's still valid even with the same function name. So the same function name can be used twice. Right here. So this is mad because of this. So yeah, right here, even though these two methods have the same function name, different parameters mean that you can do different things with them. Nested what? Yes. If you guys have talked about polymorphism, yes, that is that concept. I think it's like that, or overriding something. But yes, there is a word for that. I don't remember it. She'll be able to talk about it in like the readings or something. But so that's valid. Project 2A files are hidden still for you guys. Ooh. Let me stop my sharing. I only checked the lab. And this also, fun fact, I'm not like just pushing blame off it, but this isn't my job, but please still send, oh, never mind. Did you lie to me, Evan? The link being broken is also not good, so I'll go check it out. Okay, so I can also fix that. So I'm not in charge of managing that, but if anything is broken, just let me know. Here, I'll share my screen again. Which part is broken? So is it the video? or document in folder that's broken for you guys? So you don't have access. So if you click it, that breaks. Okay, here, I'm going to stop sharing. I'm going to fix that. This file not found. Yeah, that's probably because she updated it, but didn't update it there. Let me go look. Run linking coding. Wait, what file is this opening? You can see. Sneaky. Okay, so what file is this opening? Files, folders, projects. P2. Run length encoding. P2 image RLE PDF. It says it's published. Why can't you get access to that? Evan, you said you have access to, like, if you go to files, you have access to it. Here, Evan, can you just share your screen? Oh, here, I can share my screen. That's also, yeah, this you can see, whatever, fuck it. This isn't cheating. There's nothing here that will help you. So which file do you see that is good for you? I know there's a lot of files
Yeah, I
here.
see all of them.
You can see all of them. It's just the link specifically
Yeah, the
doesn't work.
link, it just didn't work.
So you went assignments, project 2A, and then this link right here.
The document in the folder. Yeah, and then you see how it says like image not found initially? That's what it just says that for me.
Oh, that little blip there. Weird. But you can go to files and see everything.
Yeah, well, it brings me to the file page. I just don't know what it's trying to pull up.
It's trying to pull up this one right here. So can you see this one? P2 image RLE.pdf.
Yeah.
What happens if you click on that?
It comes up.
Okay.
Well,
Well, so
the document that we should be looking at, because
yeah,
there's a lot in there.
Yeah, so this is the one you should be looking at. That's not important yet. That's not important. So these will be important when we actually start working on it, but project 2A is really basic. And I'll pull up anything that's super important. It might be, this one might also be important. I don't know, I've never seen this before, but that, I guess that's pre-work, sure. That's just, yeah, so yeah, the only one you need right now is image RLE.pdf. You might also, no, you might need RLE program.java, but yeah, we'll talk about it. But cool, okay, so everyone, to get access to the file, you can click on it and then it takes you to that like broken thing. It's not even letting me go back anymore. There we go. So click on it, it takes you to the broken thing, and then just close that and download this image RLE.pdf. So that's what we're working with. Okay, so, but cool. We'll get to that in a little bit. Keep back up. You didn't see that, so I'm going to walk over it one more time. Ernesto, so to get access to the P2 PDF, just click on the link. It's going to take you to a page. You might not be able to see it. You can't just close it and download the imaged RLE PDF. That's what you need. Okay? Just, yeah. You're eventually going to need all of these things. Technically not need all of them, but you should have all of these things. But for now, for talking about today, you just need the P2 image RLE.pdf. Okay, so we gotta keep going. Okay. And then invoking methods, we talked about that too. Awesome. Okay, cool. Lastly, in methods, this isn't really methods, scope. So anytime you see squiggly brackets, that creates a scope. So you've seen them in for loops and while loops, if statements, though if statements is not a thing. So I don't know why they told us that was what it would be. Yeah, the only one where that's not counting is if statement. Wait, let me. It's still important because if it doesn't know, yeah, so it's, but it's not, because if you do if, no, if true, I wonder how that works. And var5 equals 10. I'm just checking something real quick. System.out.println var5. Oh, nope, don't have it. So yeah, okay, cool. That's how that works in Java. That's not in C++. Cool. Okay, so yeah, anytime you see these squiggly brackets, you make what's called a scope. And a scope is a place where any variable you make inside of it, it stops existing at the end of the scope. So in this case, I initialize, so with the example I was previously messing with, so you see right here, I created a var5 inside this scope, inside these squiggly brackets. And so outside of the squiggly brackets, it no longer exists. The way you can get around that is if you do int var5 up here, and then the var5 equals 10 in there. So this is in this scope of these little squiggly brackets here. And so you can still access it in this deeper scope, that this scope is inside of this scope. But, and the changes are kept, unlike if you made it only inside this one. So this concept also exists anytime scopes are nested within scopes. So this class itself is a scope. We haven't really touched on that yet, but it is. And so if you did like int var10 up here, you could have access to var10 in here. So system.out.println var10. Technically, you'd have to do this var10. Yeah. Oh, because it's static. Yeah, because that's associated with the object. Yeah, and that's getting into static stuff. So yeah, we won't worry about class scope just yet. We'll talk about that when we get to classes. But the point I was trying to make is that you can have scopes nested in scopes, so you can make something inside this scope. So it's with this bracket, and you can access it inside of here. But this scope is not nested inside of here, so you don't have access to that. You probably experienced that a lot in project 1 when you had to keep track of information, like the number of wins, the number of games played, and that kind of stuff. You kept track of that outside of any loops or anything. Because if you kept track of it inside of a loop, it would reset at the beginning of that loop. So yeah, it also gets reset. So if we have like a while true, and like int var1, sure. I'm just gonna get rid of all this up here. So for 1, it's not accessible outside of here, but even if we do var1 plus equals var1 plus 1, if we do something like that in system, we do this, and it's gonna be an infinite loop, don't worry about it. Oh, we're gonna get rid of that too. You can still run infinite loops. So yeah, it's only ever 1. Even though we're adding to it all this time, it gets reset at the beginning of the loop. All right, let's stop that now. Okay, so that's the basic on scopes. Now an actually new concept, numeric types. So this one we're gonna sit on a little bit longer. So there's 4 number systems that we work with. you've already seen denary / decimal. I might be saying denary wrong, but it's technically called decimal, but sometimes that's confusing. So if we say like write a number in decimal notation, you're like, oh, I'll just add a dot. So it's like 10.20. So it has a decimal. But that's not what we're talking about here. When we talk about it in the concept of numeric typing, it means the number system we're using. So denary to decimal, denary / decimal is when there's 10 digits in your numbering system. So you have 10 fingers on your hands, you can count to 10, but technically you can count to 10 if you start with 1. But in our numeric system, with the digits we have, we want to start with 0. So you can count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 0 to 9 are the numbers that we have in our numeric system. 10 is just a combination of 1 and 0. Now, so that is decimal. Binary only has 2 numbers, 0 and 1. So the way you'd count that one would be 0, 1, 0, 1, 10, 11, 100, 101, 110, 111. So if you see I'm doing, I'm just adding, and here I can type it out so everyone. So you'd go like 0, oh God, let me get a text document. So you do 0, 1, 10, 11, 100, 101, 110, 111, and so on and so forth. I'll just keep going as I talk. But you can see like this is the same way we count in our system where it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so when we get to the end of the number of numbers we have, we just do 1 and we start over again, but add a digit. And so that's the same thing here. Since binary only has 2, once it gets to the end, it just starts over with adding a new digit. Technically, sometimes you might see decimal binary written out like this. Because a lot of time when working with binary, knowing all the digits that you might be working with is really helpful. But it's still the same thing, just like you could write this as adding a 0 in front doesn't do anything. So just like that, it'd be the same concept with our decimal system. So yeah, this is decimal, denary / decimal. The next one we're going to talk about is octal, which if you know oct from like octopus or something, that's 8. So instead of 2, instead of 10, there's now 8 digits. So that's 0 to 7. And so if we type this out here, it would go 0, 1, 2, 3, 4, 5, 6, 7, 10. And with this, so it does the same thing as this one down here. You just keep going. 11, 12, 13, 14, 15, 16, 17, 20. So again, it just keeps going. When you get to the end, you add a digit, and this one, it can keep going even longer. This could keep going till 77, and then it would start over at 100. With this system, an important thing to note is that, here, I wonder if Excel will do what I wanted to do. It probably won't, but we can try something. It does. Oh, perfect. Let's do that, and then actually we'll start at 1 and not 0. Delete. Okay, cool. So we're starting at 1 so it can match up here. You'll see one thing to keep a note of is that everything on the same line is actually equivalent. So in octal, the number 12 is the same as 10 in decimal, the same as 1010 in binary. One way to really show this is that you can think in our decimal system, like if that's what we're used to, which most of you theoretically are, the first digit is the first digit, and the second digit represents 10, and the third digit is 100. Well, in octal, the first digit is the first digit. That's almost always true, like translate to our system. So 1, 2, 3, 4, 5, 6, 7, that translates over easy. But when you start adding the second digit is equal to 8. So in this case, with 1, that's equal to 8. So it's 8 plus 1, 9, 8 plus 2, 10, 8 plus 3 would be 11, 8 plus 4, 12, 8 plus 5, 13, 14, 15, and then 2, it's 2 times 8, so that's 16. Same concept applies to binary, but it increases really quickly. So the first digit's 1, second digit's 2, third digit's 4, fourth digit's 8. So you guys see that? And now we're going to add our last decimal system, our last numeric system. This one, though, comes with a little caveat in that there is more than 10 digits in hexadecimal. To replace those extra digits, since we don't have a number to represent those things, we use A, B, C, D, E, and F. So don't get worried that you're like just in Algebra 1 where you got introduced to letters and math again. Don't get freaked out by it. So it's just 1, 2, 3, 4, 5, 6, 7, 8, 9. Not 10, because now we do A, B, C, D, E, F. So we'll see here, there are, it's technically 16, but I'm starting, insert. So I skipped the 0. So if we add a little 0 here. There's 16 characters, and so for the next one would be 10. There's 16 digits in the hexadecimal system. And so if you see an A, that just represents 11. B is 12, 13C, 14D, 15E. Well, no, A is 10. Sorry, I'm using the thing on the left for Excel, but remember it's down 1. So let me just move it back. Except that 0's there. There. Delete that. Okay, so yeah, A is 10, B is 11, C is 12, D is 13, E is 14, E is 15, and then again, 10 in whatever system you're using represents like it's 1 past the number of digits. So we have it's the number of digits, so it's 16 because we have 0 to 15, and so 10 is what's after 15. In this case, 16 because it starts over. So this is 1, 16, and that's 16, and so this is 16. But yeah, so these are all numeric systems. We're going to talk about conversions and how to do it more efficiently, but any questions on just the numeric systems themselves, like what values mean or how to keep counting, stuff like that. Okay, cool. Now let's go into conversions. So most of the time, it's super easy to go from any numbering system to decimal. So like if we told you to convert from octal to hexadecimal, the comfortable way would be to go from octal to decimal to hexadecimal. So it's normally nice to go from whatever numbering system you're given to decimal to whatever numbering system you're trying to get to. There are some tricks, and we'll cover the tricks, but we're going to start with just converting any numbering system to decimal or for decimal to any numbering system. Okay, so first off, the easiest thing to do is go from any numbering system to decimal. So let me zoom in on this. Let's say I gave you the number, let's say 1001, and I said convert this number to decimal. What you do is see the location of each of the digits and multiply them by 2 times their location. So starting from right to left and starting at 2 to the exponent of their location. So starting from right to left and starting at 0, we would do 1 times 2 to the 0, and put this in brackets. 1 times 2 to the 0 plus 1 times 2 to the 0, 1, 2, 3. So 3. And that equals 2 plus 1 times 2, 4, 6, 2, 4, 8. 8, and that equals 10. And if we look at this, 1001 is equal to 9. Why did I do that? What the fuck? Oh, I did this as 2. 2 to the 0 is 1. That's even I can make mistakes. Woohoo! So yeah, 2 to the 0 is 1. 2 to the 1 would be 2. Might be. So yeah, 2 to the 0 is 1, so 1 times 1 is 1, and then 1 times 8, and that equals 9. There we go. So yeah, that equals 9. Easy peasy. Now, this is true for any numbering system. So in this case, with this one, some decimal, for binary, we use 2. Let's say this was octal. Let's do octal, it'd be 8 and 8, because this number could be an octal number. None of these values are greater than 8 or greater than 7. So in this case, it'd still be 1, because 8 to the 0 is 1. 1 times 1 is 1. But 8 to the 3, now against 2, oh, what the fuck is 8 to the 3? 8 times 8 times 8. I do not know what that is. 512. And 512 plus 1 is 513. And if we go look, like an octal to decimal calculator, 1001, convert 513. So this method's super straightforward, works for any numbering system. In the case of hexadecimal, just remember that sometimes you have numbers. So let's do, if it was D A DA08, sure. It would be 8 times 16 to the 0 plus 0 times 16 to the 1. So technically you don't need to write that, but I'm still going to. Make this bigger. Plus A times 16 to the 2 plus D times 16 to the 3. And so with this little form, it's the first conversion you might want to make is getting all these numbers out of their hexadecimal version. So A is 10, B is 11, C is 12, D is 13. I'm going to go check that real quick. 13, D, yep. And so now this gets into why the hell did I make this so hard on myself? It's 8 plus 0 plus 16 squared is a number larger than I want to deal with. You'll have a 4-function calculator. 16 squared, or you can do long multiplication, but I don't want to do that. 256. Oh, it's 256 times 10, so it's 2,560. And then lastly, 16 cubed. 16 cubed. 4,096, and that's that times 13, was it? Yeah, 13, big number. Plus 53248. And I'm, again, not going to do this out because I'm probably just going to get it wrong. I am horrible at mental math. 2560 plus 8 equals 55816. And so if we just Google a hex to bind, no, not hex to decimal. Okay, so we plugged in DA08, convert 55816. Look at that, I can do math. So this is the super easy way to convert from decimal to any numbering system. Really straightforward there. Okay, so now, what about the other way around? We want to take these values and go to some other numbering system. If we want to take a decimal value and go to whatever other numbering system. So the way we do that, let's start with the basic 1001 in binary. So whatever your numbering system, in this case it's binary. Wait, hold on, no. We want to do, let's do 15. So with whatever numbering system you're in, you do 15 modulo your numbering system. Modulo is get that remainder, and so that equals 1. So we're going to do that, and we're just going to and then we're going to do 15 divided by 2, an integer division, which is so 7. And then it says this process just over and over again. So 7 modulo 2 equals 1. 7 divided by 2 equals 3. 3 modulo 2 equals 1. 3 divided by 2 equals 1. Oh, I picked a bad, well, no, it's not a bad number, but I picked a unique number. Equals 1. 1 divided by 2 equals 0. So in this case, you just take these numbers right here. And so it's 1, 1, 1, 1. I didn't mean to do that. 15 in binary is, yeah, that's 1, 1, 1, 1. So it's 1, 2, 4, 8, and 8 plus 4 plus 2 plus 1 is 15. Let's do 13. Same thing. So 13, 13, still 1. This is now 13, 6, 6. There we go. So now we have a non. There we go. Now everything else is the same though. Yes, 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 yes. Cool. So now there we go. 13 is that, and you just start from the bottom and go up 1, 1, 0, 1. So this is the binary representation of 13. So if we did binary to, decimal to binary. 13, convert, look at that. 1, 0, 0, 1. Don't worry about all this stuff down there. You'll get that into like a later class. But right there, just straightforward 1, 0, 0, 1. This works with just any numbering system. So let's say we wanted to do octal. Let's do 54. And here, I'm going to pull up a little helper. So this isn't Java, but this is going to help me do the math real quick. So 54, let's get rid of the rest of this. Modulo 8. That equals 6. And now 54 divided by 8 is in integer division is just 6. And then this is easy. 6 modulo 8 equals 6. Did I really get 66 as my number? What? How did I do that? I didn't mean to get a repeating thing again. And then 8 divided by 6 equals 0, and we're done. Decimal to octal. And if we give it 54, 66. I'm so sorry for getting a repeating number. If it was 53, it would be 5 there. And so then it would be 65. Do 3 there. So there you go, 65. Any questions on that? How is it 1110? The previous one? What was the previous? Did we do 13? So how was 13 1110? If you wanted to go from 1110 to 13, like if you want to check yourself, you can do 1 times 2 to the 0 plus 0 times 2 to the 1 plus 1 times 2 to the 2 plus 1 times 2 to the 3. Let's shrink that so it's. And that equals 1 plus 0 plus 1 times 4 is 4 plus 1 times 8 is 8, and that equals 13. So if you want to check yourself, it's that. But if you're asking me to do the process again, it's 13 modulo 2 equals 1. 13 divided by 2 equals 6. Yeah, because 13 divided by 2 in integer division is whatever you can get without, and it cuts off the remainder. So like if I showed you in this, how do you know to do this? Because I'm telling you, it's just a way to do it. Like this is just a way to get there. if you want to think about it in like, maybe she teaches you another way to do this, but if you want to think about it in like, what's the mathematical reason why this works? I'm trying to think. I've just always done it this way, but because really you're breaking it down into it's 1 and 12, and then 1, 0 is 4 and 8. 8 and 0. So doing it this way kind of breaks it down into like the 2 to the power of stuff. So doing so it's like module 2 getting 12, and then you do 12 modulo 4 equals 0, and so you're left with just 12. 13 minus 1 equals 12. And then you do 12 modulo 2. There we go, equals 0. Is it? No, it's just, no, yeah, it's module 4. It's module 4. And then 12 module 8 equals 4. And then, this doesn't seem right. And then, I'm making this up as I go, I'm sorry. 8 equals 4. Oh no, this kind of works. 12 minus 4 equals 8. And then, and then 12, and then 8 modulo 16 equals 8. 8 minus 8 equals 0. And so you still end when you get to 0, but in this case, you're fine. Modulo 2 gives you the ones digit, and then you subtract the ones digit part. And then module 2 gives you the one digit, and you subtract the ones digit. Module 4 gives you the second digit, subtract the second digit. And you have to do the resulting thing divided by the previous one or something? Yeah, divided by the previous modulo. So in this case, the previous modulo would be 1 or something. And divided by 1, divided by 2, divided by 4, divided by 8. It gives you 1, 0, 1, 1. So I think this would be like, if I like maybe the mathematically sound way to do it, like that kind of proof, like if you're doing a math proof or something. I didn't write all the proof steps, but yeah, I'm just telling you this is the way that I do it. If you have a different way to convert between the numbers, that's totally valid. Okay, but I spent a lot of time on that now. Oh, we're still in like the first period, we're fine. But so yeah, this method is how you go from a decimal number to any other numbering system. Oh, I don't like, this method is fine if you wanted to. It would be modulo the thing and then divided by, so you could think of, since you can think of the digits of like, as each representing 8, 4, 2, 1 respectively. So moduloing the higher, the digit before gives you the value of this. So like if in our numbering system, if you were trying to convert from our numbering system to our numbering system, that sounds weird, but you could still do it with this method. It would be like saying 13 module 10 equals 3. 13 divided by 10 in integer division equals 1. 1 modulo 10 equals 1. 1 divided by 10 in our numbering system in integer division equals 0. So you do this, and then it's 1 and 3. 13. Like with the bigger number, if we had it as like 9, 8, 4, 6, 8, same concept. 9, 8, 4, 6, 8. Get the remainder when divided by 10 equals 8. That number, so that number just divided by 10 equals 9, 8, 4, 6. 9, 8, 4, 6. Remainder 10 equals 6. And then that number divided by 10 equals 984. 984 modulo 10 equals 4. And you can just keep going. And you'll see as I'm doing, it's going to end up with 98468. Does that make sense? Yeah, that helps it. Okay. So cool. So now I've taught you, well, I've just kind of shown you, converting from any numbering system to decimal, and even decimal to itself, shown here, or decimal to any other numbering system. Well, this was decimal to decimal, but you could, yeah. So decimal to decimal is the same for all of it, but any numbering system to decimal is that whole taking each character, multiplying it, multiplying one, but then this is the other way around, decimal to any other numbering system. And then last but not least, there is a trick to go from any numbering system, from binary to octal and hexadecimal, and from either octodecimal to binary. So let's say our hexadecimal number was A7, 2. So in the decimal numbering system, with the hexadecimal numbering system, A represents 16 to the power. The A digit is it's 10. Well, it's A. I know it's A. It's A times 16 to the power of 3. And then 7 is 7 times 16 to the power of, no, it's 2. 2. And then 2, you times 16 to the power of 0, right? So like you do this whole thing. Well, each of these could be set equal to, so it's A times 2 to the power of 4 to the power of 2. And this is 7, and this is 2, 1, 0. So because of this fact, this whole, because 16 is 2 to the power of 4, because of this fact, if we wanted to convert this to binary, we could think about it as just converting A to binary, 7 to binary, and 2 to binary. So A in binary is 10 in binary. 10 in binary, I'm just going to tell you this. It's 8 plus 2. So yeah, A in binary, because remember it's 1, 2, 4, 8 is what it represents. So A is just 8 plus 2. 7 is no 8s, but it is everything else. So it's 4 plus 2 plus 1, 4 plus 3. And then 2 isn't 8, it's not 4, it's just 2. So that was just a shorthand by me. I'm not going to walk through each of the steps. But A converts to this because it's 10, 7 converts to that, and then 2 converts to that. And then you can just put these together in this one long number. So if we look up, I think right here, yeah, hexadecimal to binary, enter hex number A72. Convert, look at that. 1 0 1 0 1 0 0 1 1 1 0 0 1 0. So that's just a quick shorthand for that. You can just take each digit, convert it to its equivalent binary, and then shove them all together. Not add them together, because adding them together would be a little more like you do digit by digit, but you just shove them together. Kind of like adding strings if they were strings. Now with octal, same concept. If we were working with 7, 4, 6, sure. Each of these, I'm going to copy this down here because it's a very similar concept. 7, 4, 6. You might even see where I'm going. It's 8 to the 2, 8 to the 1, 8 to the 0. And that equals 7, 4, 6, 2 to the 3. So you notice here it was 2 to the 4, so we did it in groups of 4. Here now, we do 7, 4, 6. Add a little space there. 7 is, so we only do in groups of 3, so 7 does have a 4 in it, and it does have a 2 and a 1, so it's all those. And then 4, it has a 4 in it, but no 2, no 1, so it's just 4. And then 6 has a 4 and a 2, no 1. So again, did it just quick shorthand. I can do like small singular things, like I can do this specifically very quickly. And that's the setup, and then you just shove them together. And if we go to our little converter over here, I think it was this one, enter decimal number. No, this isn't one. Oh, swap. There we go. So octal number of 746. Oh, there's no binary on there. Okay, fine. Octal to binary. Enter the octal number 746. Convert. Look at that. 1, 2, 3 ones. Then a 1, 0, 0, and then a 1, 1, 1, 1, 1, 0. There you go. So that's like the shortcut. And then this also works the other way around. So I won't get rid of it just in case people have questions, but I will go way down. So if I were to give you, let's say like 0, 1, 1, 1, 0, 1, 1, sure, there we go. You can go even longer. This could be really arbitrarily long. And I said to convert this to hex, what you do is you break it up to 4, starting from the right. Make sure you do that. Start it from the right. So those 4, those 4, those 4. And if you have any left, just add zeros in front. Because remember, adding zeros in front doesn't change it at all. So starting from the right and then just keep going. Now we got this. Converting this to hex. That first digit, that's just 1. The next one is 1 plus 4 plus 8. That's 13. And then the next one is 2 plus 4 is 6. And the last one is 8 plus 4 plus 1. Oh, it's the same thing. That's also 13. Yeah, because this is the same as this. And now we have to convert this to its actual hexadecimal version. So that's 1. 13 is A, B, C, D. And then 6 and D. So you might have to do a little more work to get the 13 to D than that, just quick shorthand there. But let's go look. Here, hexadecimal to binary. Let's do binary to hexadecimal. Copy this over. Get rid of the spaces. Convert. 1D, 6D. So that's a nice little trick. The way I know how to, like, I can quickly go from binary to decimal when it's just 4 digits. So if you can't do that, that might be a little harder. But yeah, 4 or 3 digits, binary to decimal or decimal to binary, I'm really good at. So if you get quick at that, that'll make this a lot easier. But still, there's the concept. Okay, so that. Okay, awesome. This really, I think, comes up in lab 4. I'm gonna go cheat a bit, check what lab 4 is. But you know, I'm not even gonna, like last time when I gave you 1, 2, 3, that was to help you with project 1. I'm not giving you lab 4 just to work on it, but I'm gonna go look. Lab 4 actually might be, oh yeah, numeric conversion. So yeah, this will be more helpful in lab 4, but it was in the PowerPoint to go over to this. This is my PowerPoint, but I take it from what she tells us to go over today. So there's that. Any questions on numeric conversions? I can go over some, like, don't, like, if this is any confusing to you or you're like wondering why we do it, I will try my best to answer it. So if you're still confused about that, let me know, because it's definitely important. I can do it just top of my head now, so it makes sense to me. But the goal is to get you guys to that point. So any confusion at all? Does this make sense? I will happily go. Do not feel bad if you have a question. I will happily go over it again. Okay. Cool. Why didn't we close that? Okay, so that is it for. Oh no, that's not. I don't need to save that. Don't save. That is it for that from the PowerPoint today. Lastly, I'm going to go over the lab real quick. So we already went over it kind of last time, and honestly, I'm not going to take too much time in the lab. I'm going to talk about this for a second too. But the lab is basically lab 2 plus a loop. So instead of just a one-time thing, you'll have to like loop it over and over again. There's also the concept of saving this current result. So like from project 1, you can think about it as like saving your hand, but this time you just save the current result. So here menu selection is 5, so exponential. What's an easy one? 6 log. I don't know logarithms off my head. 7's exit, isn't it? Oh, display average. Oh, yeah, so it's like to display the average. It talks about it up here. I'm just gonna go up here. So displaying the average is it stores a total of all of your results and calculate the number of calculations. So that's like the number of games, number of wins and stuff. So like sum of calculations, number of calculations to average. So you just print that out just a little bit there. Sum, number, average. Now, so the sum of the calculations is not the same as the current result. The current result is just the last thing you ran. So like, let's go to here. Why did they not show any? Bruh. They didn't show any like simple ones. But so like current result at the beginning is 0, 0. But if you did like addition 5 and 2, it'd be 7. And then subtraction, the current result would be 7. But then you did subtraction 4 and 1, it would be 3. So like the current result just is the last thing that happened. It's not saving the sum like for the printing out the statistics down here. So yes, so the current result is different than the sum, but you still need to keep track of the sum of the calculations. This one's a good one to show the sum. There's also a little bit of extra credit where you can replace one of the operands with the word result, and that'll use the current result instead of that. So that's a cool little thing, taking in a string instead of a float. And so in this project, since some of the tests will have results, it's only extra credit, but if you want to do the extra credit to take in this result keyword, I don't think we didn't talk about any other error handling, right? Yeah. So since one of the things can be results, you can't use the next double anymore. You just have to use .next for the scanner, and then check to see if that can be casted to a double. So if you want to do the extra credit, you can look into that on your own, like yourself. But just a hint on that one, you have to use the next keyword to take in a string, and you have to use it for all of them, because if you use the next double and you're given that string, it's going to break. But if you don't want to worry about that, just use next double, just like you did next in the previous projects, and you're fine. Oh, and then to get the exponential, the logarithmic ones, because those are 2 added ones, just use the math library. Do we talk about that at all in here? No. But yeah, you'll be using the math library. Can I get a Geeks for Geeks link? It's not that. Tutorials, yeah, sure. Java.lang.math, sure. So it's in java.lang. I don't know if we normally include that. You normally include java.util. What the hell is that? Import Java. You normally did java.util, maybe star. Now it's import also java.lang star. So the Lang library gives you that the math stuff. This also isn't helpful for a beginner programmer. Geeks for Geeks. There we go. So if you do math library, Java, Geeks for Geeks, love Geeks for Geeks for like intro stuff. So here's a kind of usage. Oh, here's perfect. An example right here. So like ABS is absolute value. You can look into some. Do they have any? Where should you really look? Okay, so it's log and x. So if you just search for log, you'll find the log stuff, and then exp for exponential. Oh, it's POW, isn't it? POW. Oh, it's on the next page, of course. So POW is how you do something to the power of something else. So parameter and exponents are right there. So search for math.log and math.pow. And you call it just like this right here. You don't need to, like, it's not RNG or scanner. You don't need to make a variable for it. You just do math, capital M, dot pow. And in this case, A and B, A is the base, B is the exponent. So it gives great examples right here. Duplicate. And then logarithmic. Math.log right here. That one I think is more straightforward, right? Yeah, it's just log. Where's 6? It gave a 6 example. First operand, second operand. There's 2 operands for logs. Like, so that's not what you. Oh no, yes. So you also might need to remember from math how to do log stuff properly. I don't know. Yeah, I'll just talk about it. So if you needed like log of 6 with a base of 2, it's like if log 6 base 2, sure. Here, base of something else. Because base 2 is a standard thing. Oh yeah, it's right here. Oh, this is perfect. So yeah, if you wanted a log of, in this case, 6 base of 4, so if x is 6, a is 4, you can, as long as you can do log of x divided by log of a with this base and this base being the same. So you just substitute this base and this base with 10, and that gives you log of 6 over log of 4. And so that just log base 10 of 6 divided by log base 6 of 4 will give you this concept. And so that's what you'll need for here to get the first and second operand. Okay. So with that, I'm going to jump over to the project and go over part 1. Where's the assignment? Part A. So yeah, part A in here tells you what you got to do. Supposedly there's even a video for it, so that's really nice. I haven't looked at the video. But you'll just set up the first 4 requirements listed on page 2 and set up the menu for, and then set up option 1 and option 2 and 6 in the menu. So first 4 things right here is display the welcome message, display the color test, and display the menu, and then prompt for input. So you have to be able to do that. And then you'll have to make options 1 right here. Where's the option? No, not options. Oh no, yeah, so option 1, option 2, and option 6 functional. What's option 6? Display image. Display image. So the first step is definitely just to get these 4 things done. It has nothing. Basically, this is just print line statements and scanner statement to get the input. And then these right here, the load file, load test image, and display the image. All 3 of those could just be in an if statement to see if I press 1, 2, 3. So just like you did for project 1, where you did like if the user does 1, 2, or whatever, just have a really straightforward one for 1, 2, or 6. And then it's a single line in the if statement. That's all it needs. It's just a single line. You'll have some sort of variable that stores a byte array. So it's like byte variable. And you'll set that equal to either console.gfx.load file or console.gfx.testimage, depending on the if statement. And then for display image, you'll just pass it into this console.gfx.display image function. And console.gfx is a lot like p1 random. It's a file we give to you in the files folder. Console.gfx down. Maybe it's in this, it's probably in this zip file or something. Yeah, it's probably in here. I don't know why they zipped a singular file. Okay, so yeah, it's right there. So it's just this. So you just need to get that set up. And then the test images. Did they give an example of the test images? Oh, part A, even right down here. So, okay, so I talked about there, but just the test images. Did it talk about putting the text images in the right place? No. Oh, right there. Okay, so yeah. With these, you just have to put the test files folder. Yeah, so we give you this. Oh my God, download. Is it in here again? Sure, this, I'm not gonna be super strict on it. So just somehow put these, so here, if I go. Okay, so you have that, just like in P1, you can just click and drag. So just click and drag this whole file into the source folder. See what that does. It might need to be in here. We'll worry about that. I don't know where, I think it's in there. Just put it in there. It's either in here or in here when you run it. And what you'll be submitting to me is literally just a screenshot and your code. So just a screenshot of that menu working. What are they talking about in here? Mm-hmm. So yeah, once it's submitted, so it's due on Friday, and then you just submit your code and then a screenshot of your menu program that includes the test rainbow, and then the test image displayed. So actually, with just the test image displayed, like as long as you have an if statement set up for the load file, like that's not even, you don't even display it. You just display the test image. So that file structure really isn't that important. Is project 2 due Friday or just the screenshot? So it's project 2A is due Friday. So part A is due Friday. What you submit is the code so far and the screenshot. So it's the two things. It's your code and your screenshot, but it's not the whole project. It's just part A. It's really just 5 points. Like it's not the complex part of this project, promise. But that's due this Friday. Okay. There's a submission on Canvas for it, part 2A. Yeah, so you submit it to Canvas right there. Okay. Awesome. Cool, cool, cool. When the code is complete, that's what, Ernesto? Yes, it's part in assignments, part 2A. You should be able to see that. You submit the code and the screenshot. And then supposedly there's a little video to help, so hopefully that'll be good. Okay, with that, I think we have like 30 minutes left. Schedule. Ooh, less than 30 minutes. So let's get this going. So with that, I'm now going to assign some groups. So the way pair programming works, we haven't done this yet. The way it works is that I will be splitting you guys up into groups of 2. So you as well, you'll have to get on the Zoom if you want to participate with this. And since there's no one else here, you don't have to if you don't want to. But I'll be splitting you guys up into groups of 2. It'll be randomized. And you guys can talk about whatever you want. Talk about the assignment, talk about issues between each other, help each other out. The goal is that by talking through the project, talking through the lab with someone else, you'll get like a better understanding of like your issues, about where you're at. Maybe someone else's perspectives will be really good. And you are allowed outside of this class to work with them on this specific lab. So it'll change. It won't be a concept for projects, but with the lab, this one specifically, you're allowed to work with that other person. Just make sure in your submission, if you work with them, put a comment about it. So I'm going to split you guys up now. If you don't want to do this, just like, I don't, but this is also where I'll be answering you guys questions. So put in your breakout rooms and I'll hop between the breakout rooms to answer questions. This will be the person that you're working with. If you don't want to work with, here, actually, because I don't want to put someone who doesn't want to work with anyone with someone that does, because that would fuck up the person that does. If you, here, let me break out there and then breakout rooms, assign manually, 3, create. Okay, so if you do want to work with someone, raise your hand. And there's like a little reactions button, just, oh, there's no raise hand. Do like thumbs, or actually you can raise your hand in the participants view, right? Just react or do something, or type it in the chat that you want to work with someone. Hello, Stuart. Okay, so Stuart, so assign, Stuart, there we go. Okay, John. Anyone for John? If we end up with an odd number, I'll make like a group of 3 and that's okay. So anyone else? Going once? Going twice? Did someone? Okay, so I will assign John with them. John. Okay, cool. So now you 3, Evan, Jed, Kale, you guys are working by yourselves, but I'll still put you in a breakout room and I'll just come by. That's what I'll use for questions. So delete. And Kale, here we go, open all rooms. So you guys should be able to join the rooms now, so go into them. Yes, yes, yes. There we go, okay. Okay, so first, do you have any questions? What's up? Is it on Zybooks? What about it? What's up? Well, you can just make a new project then. So here, like right here. Okay, well, if you join the Zoom call, I can look at your screen and we can walk through it. Okay, while you're working on that, here, I'm gonna also stop recording.